Our one definition for this lesson comes in this section of the lesson. It says a radical expression is simple in simplified form does not have a radical in the denominator. Most frequently, the denominator is rationalized. You rationalize the denominator by simplifying the expression to get a perfect square under the radicand in the denominator. So we have the square root of a over the square root of b times 1 equals the square root of a over the square root of b times the square root of b over the square root of b. That would equal the square root of ab over square root of b squared. That would equal the square root of ab over b. Notice that our final goal is to get the denominator to have no radical sign. They've got a couple of examples worked out. We're going to look at A through C here at the bottom. We're going to look at A through C here. We have the square root of 11 over the square root of 6. Now, 11 divided by 6 is not going to simplify. It's not going to come out to be a perfect square. So we multiply by what we call a well-chosen 1. And that 1 is going to be the square root of 6 over the square root of 6. B over B. That makes this the square root of 66 in the numerator position, but the square root of 36 in the denominator. Well, can anybody simplify the square root of 36? It's simply 6. So I have the square root of 66 over 6. Notice I do not have a radical anymore in my denominator. I have rationalized. Square root of 66 over 6. Let's take a look at B. B states 2 square root of 7 over the square root of 5. We're going to multiply by this well-chosen 1, and that 1 is going to be the square root of b over the square root of b. So whatever is in your denominator position. So we're going to do square root of 5 over square root of 5. Well, the 2 is going to stay outside as a coefficient. And 7 times 5 is underneath the radicand, so it's going to be 35. In the denominator, we're going to have the square root of 25, because 5 times 5 is 25. And we know that that's a perfect square. You kind of set it up that way whenever you multiply it by itself. So we have 2 square root of 35 over 5. So that was 2 square root of 35 divided by 5. All right, let's look at our last example here. C. 3 square root of 5 divided by the square root of 8. Multiply by that well-chosen 1. Square root of 8 over the square root of 8. This gives me 3 square root of 40. In the denominator position, I have the square root of 64. Now, it looks like we can do some simplifying both the numerator and the denominator position. This, I can make 3 square root of 4 times 10. And in the bottom, I know that that's 8. What is the square root of 4? 2. So we've got 3 times 2 square root of 10 divided by 8. Can we simplify that? 3 times 2 is 6 over 8 square root of 10. But we can simplify this even more. What number goes into both 6 and 8? 2. So my final answer is actually 3 over 4 and the square root of 10 in the numerator position. So that was 3 square root of 10 over 4. Rationalizing the denominator. Multiplying by a well-chosen 1. That well-chosen 1 is going to be the square root of b over the square root of b. And then simplify in the end. On to the vocab wrap-up of this lesson.